But before we start, let me introduce myself. My name is Frederick Octo Ramadani, and I'm a student at Telkom University Bandung in class of 2024, and today I will explain the material of external memory and also cache memory. But first of all, let's dive into external memory first. Then we will talk about cache memory later. Okay. Okay, first of all, let's start with the question, what is external memory? Okay, as we can see the definition, external memory, also known as secondary storage, is used to store data permanently outside the CPU and main memory. Its main purpose is to handle large amounts of data efficiently and to store information that doesn't fit into main memory. Examples of an external memory include magnetic disks, optical disks, and magnetic tabs. Okay, let's talk about next material. External memory is the part of the memory hierarchy, which organize memory types based on speed, cost, and also capacity. As we move down to the hierarchy from registers and cache to external memory, the cost per bit is decreases. Capacity is increased, and access time becomes slower. Yeah, external memory is accessed less frequently than primary memory, but plays a vital role in storing large amounts of data. Magnetic disks are a common type of external memory. Data is read and written using a read or write head. Okay, this read or write head. While the disk spins underneath it, so the spins, this rotation, data is organized into circular tracks, which are further divided into sectors separated by gaps to prevent interference. Okay, let's see the performance factor. Okay, performance of magnetic disks. It depends on these three factors here. The first one is seek time, the time to move the head to the correct track. The second one is rotational delay, time to rotate the disk to the desired sector. The last one is transfer time, time to transfer the data. Let's talk about optical memory. Okay, as we know, such as CDs or DVDs or Blu-ray discs, stores data in the form of bits and lines on the surface of the disc. A laser beam reads the reflected light patterns from these bits and lines to retrieve data. Optical memory is durable and has longer lifespan compared to magnetic disks, but it's slower and has a constant data density regardless to the disk's position. Let's move to the rate or redundant array of the independent disks. RAID is a system that combines multiple physical disks into one logical unit. It improves both the performance and reliability of external memory. Common rate and common rate mm, levels include rate 0, rate 1, as we can see here, rate 0, rate 1, rate 5, and rate 6. Okay, data stripping, mirroring, stripped data with parity, and the last dual parity. And this image represent the red 0, 1, 5, and 6, as we can see here. Okay, let's move into performance parameters. Okay, to evaluate the performance of external memory, we consider several parameters, such as the first one is seek time, the time needed to move the head to the desired track, and the second one is rotational delay, the time required for the disk to rotate to the correct sector. The third one is access time, the sum of seek time and rotational delay. The last one is transfer time, the time it takes to transfer data once it's accessed. Like for example, if the seek time is 4 ms or millisecond, and rotational delay is 4 millisecond, and transfer time is 8 milliseconds, the total time it will be about 16, yeah, 16 milliseconds. Okay. um, I will make a conclusion. I just want to sum up what we have taught, discussed, or explained. Um, okay, external memory is a crucial component of computer systems, providing permanent storage for large datasets. Examples include magnetic disks, RAID systems, and optical memory. Maybe the performance of external memory depends on parameters like seek time, rotational delay. Yeah, that's all. And by understanding these concepts, I think we can design more efficient and reliable computer systems. And okay, that's all I think for the conclusion. And let's move into memory cache, the second material of the day. Okay, what is cache memory? Cache memory, I think oh no, I mean cache memory is a small high-speed memory that sits between the CPU and main memory. It temporarily stores frequently accessed data and instructions, providing much faster access times. Most modern systems implement a hierarchy of caches like L1, L2, L3, decreasing speed in but decreasing in speed but increasing in size as you move further from the CPU. How will it work then? Okay, cache memory explains two fundamental principles. The first one is sorry. The first one is temporal locality. Second one spatial locality, and the second one is spatial spatial locality. Nearby data likely needed tags. When the CPU requests data, it first check the cache. A hit a hit. This a hit means the data was found, while a miss means it must be retrieved. from slower memory. Okay, moving to the next material, catch performance metrics, measuring effectiveness. We measure, we measure catch performance primarily through hit rate, the percentage of memory access that find their data in the cache. The effectiveness of a catch depends on maximizing hits while minimizing misses. A system's overall memory performance and can be calculated using the average memory access time formula. So that yeah. And now for a conclusion. In conclusion, cache memory is a fundamental solution to the processor memory speed gap. By exploiting locality principles, caches dramatically improve system performance. As computing demands continue to increase, cache design remains a critical area of computer architecture research and development. That's all for material today. Thank you so much for watching, and and see you in the next video.